Vietnamese engineering students possess incredible mathematical intuition. They have the raw analytical potential to solve complex problems and see how systems lock together. But having the math skills on paper doesn't automatically translate to building the hardware that powers our global networks. Right now, there is a severe shortage of practical, hands-on ability in highly specialized fields like telecommunications and antenna engineering. Examining this flowchart of a standard university curriculum reveals the core problem. The system operates as a closed loop between the textbook and student. There is no off-ramp for industry application, largely because educators lack access to modern research and development facilities. To break this cycle and actually equip students with market-ready skills, the intervention has to happen at the top. You have to completely retrain the teachers. This is the exact purpose of the TMA training program for university lecturers. It operates as a direct pipeline designed to take academic talent from classroom chalkboards and plug it straight into the global tech industry. The first stage requires physical space. At the TMA Vietnam Antenna Design Center, the focus shifts entirely to telecommunications hardware. University lecturers are brought out of lecture halls and embedded directly into these physical labs. They collaborate side by side with leading U.S. technical experts, transitioning from teaching pure theory to conducting active, hands-on research. They also step into the role of teaching assistants for an intensive 6-month training course offered entirely for free to promising students under the direction of Dr. David Neum. The curriculum aggressively pushes both educators and students past standard textbook equations. They must master modern design simulations and run rigorous stress tests on current high-end testing equipment. Then comes the ultimate test of their new skills. They don't just model the hardware. They have to actually fabricate and build fully functional antenna prototypes. That hands-on fabrication is what turns abstract mathematical equations into tangible infrastructure. It ensures an engineering workforce is prepared for the daily demands of the telecommunications industry. Once a physical prototype exists, the challenge changes. A working antenna is great, but getting it into the market requires the TMA Innovation Program. Navigating the commercialization process is complex, so the program utilizes artificial intelligence as a strategic partner to guide these projects from the lab bench to the real world. This pipeline maps the commercial lifecycle. AI processes massive data for these first stages, executing exhaustive patent searches and assessing commercial viability. This assistance continues, optimizing operational management, constructing marketing strategies, and securing launch funding. However, AI is strictly a predictive tool. Every output, patent search, and commercial projection requires rigorous verification by the educators to guarantee legal compliance and accuracy. By integrating this software ecosystem, the program removes subjective guesswork from the equation. Academic research becomes a highly calculated, data-driven commercial pursuit. Localized innovation is a strong start, but scaling these commercial technologies requires direct access to the global stage. This is where the Talented Minds Agency, TMA's educational consulting branch, steps in. Their focus is identifying top-tier talent and mapping out long-term international career paths for them. The system relies on a very pragmatic exchange. Right now, heavily funded professors at universities in the United States and Australia have major R&D projects, and they desperately need highly capable minds to execute them. In exchange for contributing analytical labor to these high-level projects, top Vietnamese academics earn world-class master's and PhD degrees from prestigious universities, fully funded by scholarships. It effectively dismantles the walls around isolated local classrooms. By securing these placements, Vietnamese educators and students are plugged directly into the highest, most competitive tiers of international research. If you step back and look at the entire TMA pipeline, the role of the Vietnamese university lecturer has undergone a total evolution. The model on the left represents the traditional isolated lecturer. The version on the right is an active researcher, integrated into a global R&D network and capable of turning data into commercial technology. Providing consistent access to hardware labs, AI tools, and international scholarships creates a permanent bridge between local universities and the global market, replacing theoretical cycles with technical infrastructure. This is the step-by-step blueprint required to take raw, untapped analytical potential and forge it into the next generation of global telecommunications engineers. This pipeline is a rapidly expanding ecosystem. For ambitious educators and students looking to integrate themselves into this network, The first step is reaching out through the TMA contact page.